All right, Matthew, here we go. We've got 5-5 trapezoids. And our question for this one that you need to answer at the end is, what are the similarities and differences between trapezoids and parallelograms? So what does a trapezoid have in common with a parallelogram, and what is different about a trapezoid and a parallelogram? So give me some answers on that. Remember, you answer the questions at the end of your notes as like a summary or something. All right, so trapezoids. We got three basic types of trapezoids. The definition of a trapezoid is it's a quadrilateral with only one pair of parallel sides. So remember, the parallelogram had two pairs of parallel sides, but a trapezoid only has one pair. So there's a similarity and a difference in parallelograms and trapezoids. And hopefully you'll see some other similarities and differences. So if I've got a trapezoid, then I know that I've got one side that's parallel to the other side. And what we have here is we got two different bases. We call this one of our bases, so like base 1, and this one we might call base 2. And then over here, these parts that are not parallel we call legs. All right, so when we've got a trapezoid, just any kind of trapezoid, because these are parallel, look at these two angles here. Those are same side interior angles because this would be a transversal and these would be parallel lines. So we could say that the measurement of angle 1 plus the measurement of angle 2 is equal to 180. So those have to be supplementary because they're same side interior angles. And we'd also see that the measurement of angle 3 plus the measurement of angle 4 for the same reason would also be 180. So that happens every single time with trapezoids because of same side interior angles. So that also happened with the parallelogram. So that's another similarity right there. Okay, a right trapezoid. So again, it's a trapezoid, so we've got parallel lines. The right trapezoid is when one of the legs is perpendicular to the two bases. So here we've got a leg, and this leg is perpendicular to both bases. Again, 1 and 2, they're going to be supplementary because they're same side interior angles, and these, of course, 90 plus 90, that's 180, so those are supplementary. Now, in an isosceles trapezoid, still a trapezoid, so these are parallel. In isosceles trapezoid, what we see here is that these two angles are exactly the same on both sides. And they're still supplementary. The measurement of angle 1 plus the measurement of angle 2, they're 180. These are same side interior angles. Now, in isosceles, the legs are congruent. So really what you have here is like an isosceles triangle where we've cut off the top part of the triangle. So remember, in an isosceles triangle, the base angles were congruent. So here we've got base angles that are congruent. 2 and 2 are the same, and 1 and 1 are the same. All right, so let's look at some of our properties of an isosceles trapezoid. Property number 1, each pair of base angles are congruent. So that's what we're saying up here, is that here's one of my bases down here, so this is a base down here. It's a trapezoid because these are the same. It's isosceles because these are the same. So this base's angles are the same as this one over here. So those base angles are congruent. And then the other base, that's what it means by each pair of base angles, because this is a different base up here. Then those angles there would be congruent to each other. Let's call it base 2. So what we would expect to see here is that these are still going to add up to 180 degrees because of same side interior angles. But now, in addition to that, these two are the same and these two are the same. So if this is 70 and this is 70, this would be 110 and this would be 110 because they have to be supplementary same side interior angles. The other thing that becomes true is the diagonals are congruent to each other. So if I've got my diagonals drawn on there, let's do it in pencil. So here's a diagonal here, here's a diagonal here, and let's call this A, B, C, and D. So we would know that the length of BD is going to be congruent to AC. All right, last thing you need to know about trapezoids is the midsegments of trapezoids. So in here, we've got a base one on top. Could be base two, doesn't matter which one's which. And we've got a base on the bottom. Call that base two. Midsegments, we did these with triangles. Remember, midsegments connect the midpoints. So that means that this segment here and this segment here are congruent. And this segment here and this segment here are congruent. So that means those are midpoints. And just like the triangles, the midsegment is parallel to the base. Parallel P. Parallel to both bases. So here, here, and here, all three of those would be parallel to each other. These two would be parallel because it's trapezoid, and then the midsegment is parallel to both of those. Second thing that we would know is the midsegment is the average of the bases. Meaning that this length is halfway in between these two. So how do I find the average of something? Well, what I would do is I'd just say, okay, so the midsegment, MN, it has to be AB plus DC divided by 2. That's the average, right? You would take this one plus this one, divide by 2. MN is halfway, so it's the average is halfway in between them. Now you can write that equation, or if you don't like dividing by 2, because remember we ran into problems with dividing by 2 when the numbers were not even, what you could do instead is do 2 of the midsegments is equal to AB plus DC. And those are equivalent equations. They're the same thing. All right, math hard. Keep on doing your work. Write your summary. Write all the similarities and differences that you could find between trapezoids and parallelograms. That's all I got for you. Be good.